Everyone. Uh, I am going to go over some questions from our section review 8.1 on page 266. So if you're looking at your textbook online or if you have a textbook at home, you guys can see we're going to go over the first 6 problems in this video. So some of the questions are pretty straightforward and I'm sure you guys already have the answers to, but I want to be able to go over them now that we're really not face-to-face, so we can't ask even simple questions very easily. So the first question is pretty easy. It is, what is a chemical reaction? So if you look on page 260, so page 260 has our definition of a chemical reaction. So I'll just turn to that page for you. So the definition for a chemical reaction is the process by which one or more substances change to produce one or more different substances. So that's the answer. That's what a chemical reaction is. But just to say it in layman's terms, this is when we start with 1 or 2 or any number of things, and then we end up with a new product. It has to be completely new. We can't just rearrange the stuff that we started with, which we call reactants. We now have products. So those things need to be completely new substances, and that's what a chemical reaction really is. The next question is, what is the only way to prove that a chemical reaction has occurred? So if you went through the textbook and read all of the pages and whatnot, you guys should be able to give me an answer in your own words. Something that I would kind of say, again, just not using textbook terms, but to know that a chemical reaction happened, we needed to take our reactants or just stuff, right? Whatever we had to start with, and it turned into different stuff. Those are our products. Then we have a chemical reaction. We know it took place and we know it occurred. Whereas if we are starting with solid water and we end with liquid water, aka ice that melts, that's still H2O. Did a chemical reaction occur there? No. So that is a physical change, which we talked about way in the beginning of chemistry, but our physical changes don't always necessarily mean that we have a chemical reaction. Number 3, when water boils on the stove, does a chemical change or a physical change take place? So similar to the example I just gave, we're going from what to what? So we put water in a pot, put it on the stove, it starts to boil. So the water that we start with is what phase? Liquid, right? So it's at liquid form, and then we add heat to it, and then we have all these bubbles, and what's happening on top of the water, the liquid water, is steam, which is gaseous H2O. So that means that we went from liquid to gas. That means we had a physical change. Can that gas turn back into a liquid? Theoretically, yes. It's going to be hard to kind of catch all your steam, but if you ever notice when we have condensation on stuff, that is steam water, steam H2O, going from gas back into the liquid phase as it starts to cool. All right, so number 4. All right, give 4 examples of evidence that suggests that a chemical change is occurring. All right, so I wrote my answer with a note on top of it that says Table 1 at the top of page 261. All right, so if you look at Table 1, it actually is called Evidence of Chemical Change. All right, so they list some changes in energy and formations of new substances, aka physical changes that are examples of a chemical reaction, and we have brand new things, meaning a chemical change that presents a chemical reaction. So 4 examples of evidence that suggest a chemical change, pick 4. All right, we have formation of gas, formation of precipitate, change in color, change in odor. Those are the ones I would more so say those are definitely things that would say that we have a chemical reaction, because those are when we have a new formation of a new substance, okay? The stuff that has changes in energy, I wouldn't necessarily list, because we might have a release of energy as heat, and it could or could not be a chemical change. So I would list the things that you see underneath formation of new substances, those 4 bullet points, and that's your answer. Number 5, and number 6 goes with number 5, but we're gonna go over them one at a time, all right? So number 5 says, when propane gas, C3H8, has burned with oxygen, the products are carbon dioxide and water. write an unbalanced formula equation for the reaction. So one of the questions that I did get on Google Classroom was, what the heck is up with this unbalanced formula stuff? So in the next section, we're going to learn how to balance formulas. So it kind of looks silly for them to say and specify unbalanced formula right now because we never learned how to balance. It's the only kind of formula we know. So don't worry, don't stress out about that too much. We'll go over that next week when we go over Chapter 8, Section 2. So an unbalanced formula equation means we're going to have our formulas with plus signs. We're going to have an arrow that means yield. That's going to be our difference between our reactants and our products. And we're just going to list everything that they told us in a sentence form. So if we break it down, they list to us propane gas, and they tell us what propane is, right? So we have C3H8 is propane gas, and it burns with oxygen. So if we know it's going to do anything with oxygen, we're going to add that plus sign, and then we're going to write O2 for oxygen. Now, why am I having 2 oxygen atoms and not just 1? That's because oxygen is a diatomic molecule. And I'll write that here. Diatomic molecule. And there are 7 different elements on the periodic table that are diatomic. They are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Okay, so if you guys want to, in your notes, which I highly recommend, write down these 7 diatomic molecules. If you don't write it down right now, you can definitely Google it after this, and they'll have a list of the 7 molecules for you. But these are the ones that you want to keep an eye out for whenever you're writing your formulas, because they're always going to be a diatomic molecule if they're by themselves. Okay? So back to the question, right? So unbalanced formula equation. So far we have our reactants. That's what we always start with. And I'll write that there. Reactants. After you list your reactants with a plus sign, you're going to write your arrow, which is yield. Okay? That arrow right there means yield. It just means, you know, the products you're going to yield, not yield like in traffic where you slow down. So we have our 2 reactants, yields. Our products are carbon dioxide, which we know is CO2, and water, which is H2O. Okay, and what do we call on the left side of our arrow? Those are our products. All right. So the answer for, this is number 5, I'll just put that up in the corner so we know what we're talking about. Number 5 is what you see here. We have C3H8 plus O2 yields CO2 plus H2O. All right? Now, number 6 is piggybacking on number 5, and it says, I have it written down, let me see. Number 6, oh my gosh, I'm on the wrong page. There we go. Assume that liquid water forms in item 5. Write a formula equation for the reaction that shows the physical states of all compounds. So this is really easy. I know that sometimes we read these questions and we think, oh my God, what's all this mumbo jumbo? So all it's asking us to do is take what we have from question number 5, and we're going to add in parentheses after each of our formulas what state of matter it is. So, and we can pick up clues from the sentence they gave us in number 5. So let's read through it again. When propane gas, so what state of matter is that? Gas. So you're going to go right after your formula here for propane and just put in parentheses a G for gas. All right? It's not the prettiest G I've ever written, but there it is. Let me rewrite it actually. It's ugly. Okay, so we have propane gas, and then we have O2. What is oxygen's state of matter? If we read here, do they have any hints for us? Burned with oxygen? No, they don't tell us, right? But if you think about it, is oxygen in the air we breathe? Yes. So it must be a gas. So we're going to write the same thing, parentheses G, right after where we have O2, right? So now we know that we have propane gas and oxygen gas. Moving on, we say the products are carbon dioxide and water. So carbon dioxide, again, you guys should know that's just from common sense, right? So carbon dioxide, when we breathe in oxygen, what breathes out? Carbon dioxide. So we know that's a gas. And then what information do they give us in number 6 about the water? It says specifically, assume that liquid water forms. So we know that that state of matter is liquid. So let's add in CO2 gas and H2O L. So here we go. I know it's a little jumbled up at the end there, but that's number 6, all right? We have our formula equation with our states of matter, as you see here, gas, 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 and liquid. All right, lowercase g's and lowercase l for the liquid there.